hope you all are doing well. In this video, I'm going to take one of the question from chapter 8 Trigonometry of class 10. And in this question, we have to prove one of the identity. Okay. So here the question is 1 plus tan square A upon 1 plus cot square A is equal to 1 minus tan A upon 1 minus cot A whole square is equal to tan square A. Is this question? We have to prove this left hand side and right hand side. There are two of them. Okay. So we can solve either we will take this and we will prove this right hand side tan square A. And in the next, we will take this question 1 minus tan A upon 1 minus cot A whole square is equal to tan square A. Okay. If this identity will be equal to tan square A and this identity will be equal to tan square A, it means they will be equal to one another. Okay. So I am taking first I am going to solve and I am going to take this 1 plus tan square A upon 1 plus cot square A is equal to tan square A. First we will prove this one, okay? So in this I will take the left hand side, okay? The left hand side. It is given 1 plus tan square A upon 1 plus cot square A. So we know that, okay, we know that 1 plus tan square A is equal to sec square A, okay, and 1 plus cot square A is equal to your cosec square A, okay. So in this 1 plus tan square A, in its place we can write sec square A upon, and in place of 1 plus cot square A, we can write cosec square A. Okay. And we know that sec A can be written as 1 by cos A and cosec A will be written as, can be written as 1 upon sin A. Okay. And as it is in square, we can write it as 1 upon cos square A, okay, divided by 1 upon cosec can be written as 1 upon sin A, or you can say it is cosec square A, so we can write it as 1 upon sin square A, okay. That follows 1 upon cos square A. When we write its reciprocal, the division sign changes to multiplication. We get the reciprocal as sin square A upon 1. Okay. Now sin square A upon cos square A. We know that sin A upon cos A is equal to tan A. So sin square A upon cos square A will be equal to tan square A. That is equal to our right hand side. Okay. So we have proved this one of the identity, and that is equal to the right hand side tan square A. Okay. Now we are going to take 1 minus tan A upon 1 minus cot A whole square. Okay. This is 1 minus tan A upon 1 minus cot A whole square. Okay. We are taking the left hand side. Now we can expand 1 minus tan A upon 1 minus cot A, okay, whole square by the formula of A minus B whole square. A minus B whole square is equal to A square minus 2AB plus B square. Okay, so here it is A is 1 and B is your tan. So it will be written as 1 square minus 2 tan A plus tan square A. Similarly, the denominator will be also expanded using the formula identity A minus B whole square. It will be 1 square minus 2 cot A plus cot square. Okay. Now in the next step, it will be 1 minus 2 into tan A can be written as sin A upon cos A. So in place of tan A, we can write sin A upon cos A plus tan square A can be written as sin square A upon cos square A. Similarly, in the denominator, cot A can be written as cos upon sin. So 1 minus 2 into cos A upon sin A plus, and cot square A can be written as cos square A upon sin square A. Okay. Now this cos A we will be taking as the LCM as cos square A. Okay, and so in place of cos A, cos square A, cos 1 cos A is there, so we can write it as 1 minus 2 into sin A into cos A, okay, plus sin square A. Why sin square A? Because cos square A is there, so we will multiply it with 1, okay, divided by, okay, now it will be sin square A. Sin A, and we will take the LCM of sin square A, it will be sin square A. So sin A is there, 1 sin A we have to multiply, so it will become cos A into sin A plus cos square A. Okay, now in the next step it will be cos square A. This cos square will be multiplied here, so it will become cos square A minus 2 sin A into cos A plus sin square A. Okay, similarly we will take the LCM of 1 and sin square A, it will be sin square A. So the sin square A will be multiplied in the numerator, we get sin square A minus 2 cos A into sin A plus cos square A. Okay, now we have to use cos square A plus sin square A. We have one identity that sin square A plus cos square A is equal to 1. So cos square A plus sin square A. Okay, cos square A plus sin square A, we know that sin square A plus cos square A plus sin square A is also equal to 1. Okay, so in place of cos square A plus sin square A, we can write as 1. Okay, 1. Now minus 2 sin A into cos A upon cos square A divided by sin square A plus cos square A, we can write as 1 minus 2 cos A into sin A upon sin square A. Okay, now this division sign will be changed into multiplication, so it will be 1 minus 2 sin A into cos A upon cos square A multiply. When we change this division sign into multiplication, the reciprocal we get the sin square A upon 1 minus 2 sin A into cos A. And this 1 minus 2 sin A into cos A and this 1 minus 2 sin A into cos A will get cancelled, and we get as sin square A upon cos square A. And we know that sin square A upon cos square A can be written as tan square A, and that is equal to our right hand side. Okay, so we have proved that both this left hand side is equal to right hand side. If two identities are same or equal to the same identity, it means they are equal to one another. Okay, it implies that the other two identities are also equal to one another. Okay, so hope you understood the explanation that I expect that if you have not yet subscribed to the channel, then kindly subscribe to the channel and don't forget to hit the like button. Thank you.